Let's now take a look at factoring the binomial y to the fourth minus 81. Now, as with any factoring problem, we first want to check to see if there's a common factor other than 1 that we can pull out of both terms. In this case, I think you'll agree with me that there is not a common factor other than 1 in y to the fourth and 81. Now, because it's the difference of two terms, the only options we have for factoring here would be either the difference of two squares or the difference of two cubes. I think you'll agree with me that neither of the terms would be considered perfect cubes, so the only option we have would be to tackle this as the difference of two squares. Now, before we do that, let's remind ourselves of what the formula is for factoring the difference of two squares. If we have a squared minus b squared, that will factor into the difference of the square roots of the two terms multiplied by the sum of the square roots of the two terms. Now, what we might do here to make our job a little bit easier is to rewrite the original two terms in the following way. We'll write y to the fourth as y squared, quantity squared, and the 81 then as 9 squared. So in this form, I think you can see that the a in the formula above would correspond to y squared, and the b would correspond to 9. So now what we have then as our first step would be to write the difference of the square roots of the two terms multiplied by the sum of the square roots of the two terms. Now we have a factored form of the original binomial, but we need to ask, is it a completely factored form? Now if we look at y squared minus 9, I think you can see that that is pretty easily recognizable. It's also the difference of two squares. Now if we like, we could write this as y squared minus 3 squared. We may not need to do that, but I will right now, just to show how it fits the general factored form that we have above. So this will factor then into the difference of the square roots, which would be y minus 3, times the sum of the square roots, which is y plus 3. Now recall that the sum of squares, which is y squared plus 9 in this case, can never be factored. So we then have as our final answer for this problem, the quantity y minus 3 times the quantity y plus 3 times the quantity y squared plus 9.